The pressure of oxygen, O2, in a 19.8 liter flask is 779 millimeters of mercury at 88 degrees Celsius. What is the mass of O2? And I'm sure you've noticed by now, but there's oftentimes a space between these two. I have not been able to fix that. I apologize, but hopefully it still works for you and you still know what I mean. In this particular problem, I have a volume, I have a pressure, and I have a temperature, so we're definitely talking about gases here. We know that oxygen is a gas as well, and it's asking for the mass. And this is an equation we will use quite a bit. It's called the ideal gas law. PV equals nRT, PivNert if you will. And these are very often, and this is the case here, what are called plug and chug problems. You know, you have information about all of these variables except one. You can solve for it, and then, and that's what you need for this problem, though there are some unit conversions to do. Like I mentioned in the videos, my way of solving this is I plug in all the numbers and then I rearrange the numbers, or I do the math part. Looking at this, from the lecture outlines, you'll know that R is 0.08206, and those has units of liter atmospheres per mole Kelvin. That means that when I plug all these numbers in, my millimeters of mercury pressure has to be converted into atmospheres. So I'll start by doing that before I plug it in. From the conversion and equation sheet, I know that 760 millimeters of mercury is 1 atmosphere. (1.025) or to 3 sig figs 1.03. My volume is in liters, so I'm good there, but my temperature is in degrees Celsius. K for Kelvin is going to equal degrees Celsius plus 273.15. The 0.15 rarely makes a difference in this class. For example, you can see that my temperature here is just 88 degrees. So to the ones place, I just need to add the 273. I get 361 Kelvin. And now I have everything I need. I'm going to start plugging things into the ideal gas law. My pressure, 1.03 atmospheres. My volume, 19.8 liters. My moles, N, is what I don't know and what I will eventually convert into mass. My R value I do know. And my T value I do know as well, 361 Kelvin. So to solve for N, take the two numbers next to it and divide both sides by them. My math for this is going to be 1.03 times 19.8 divided by 0.08206 divided by 361. And I get 0.688 moles. And the ideal gas law, as I talk about in the lecture outlines, means this could be any gas. The ideal gas law works for any gas, and it works well around room temperature and pressure conditions, which we are at more or less. But since the problem asks about oxygen, we know this is O2. And to get the grams, we need the molar mass. Molar mass is 32 grams per mole. And multiplying that out Again, I always go back when I work these problems to the numbers that I've put down on the page. 0.688 times 32, 22.0 grams of oxygen. Any questions about that?